Thank you all so much for coming. My name is Rohini Goyal. I'm a program manager at Microsoft, and I'm here with my colleague.
Hi, everyone. I'm Anand Yadav. I'm also a program manager in the Azure Identity division.
And we're here to talk to you all about how you can ensure your users have strong passwords by using Azure Active Directory Password protection. As Microsoft has a very large user base, we see literally billions of login requests come in all the time. And oftentimes, some of these are made with a malicious intent. As we all know, hackers are constantly trying to guess our users' username and passwords. Quick show of hands, how many of you have a password that starts with a capital letter or ends with an exclamation point or a number, right? These are the issues that organizations face. Oftentimes, users will configure passwords that aren't that strong, and this leaves your organization at risk and vulnerable to attacks. Year over year, we've been seeing a gradual increase in the number of identity-related attacks. In fact, in just August of this year alone, we blocked 1.29 billion authentication requests. And this is when we actively saw a bad actor trying to guess a user's username and password. Many of these authentications that we blocked were due to password spray attacks. So password spray attacks are when you have a bad actor that has a set of passwords, and then they use these set of passwords against a group of accounts. The hope here is that this set of passwords is common enough amongst these set of accounts that hopefully of these multiple attempts, one of them will be successful. Now the thing is that in order for a bad actor to do any sort of damage, they don't need to gain access to a VIP account. If they get access to just a normal employee's account, they can then use this account to request access to privileged information. And by the end of that attack, you have someone outside of your organization that has your sensitive information. And well, we all know what can go wrong if that happens. 81% of data breaches involved weak, default, or stolen passwords. Now, the worst part about all of this is that hackers are actually kind of smart. They know that the passwords that are really easy for us to remember are also the ones that are very easy for them to guess. And they leverage this knowledge when they're performing a password spray attack. They are sure to choose passwords that are most likely to be used by everyone here. And this is very nicely reflected by some of the passwords that we see in attacks. Normally, they include words such as the word password, the different seasons in a year, different years, or even just a sequence of numbers in a row. So the common passwords that we see derived from this short list can include things such as password 1234 or spring 2018. The good thing is that Microsoft does have a lockout policy in place. So the premise here is that after multiple failed sign-in attempts, we do lock the user's account. But the thing is that, once again, hackers are smart. They know that we have this service in place, so they only have a limited number of attempts to guess a user's password. So when they're planning an attack against your organization specifically, they're going to use words and phrases that are most likely to appear in passwords from your users. And this can include things such as the name of your company. So it could be like the name of your company 123. Names of people in your management, that are well known across your organization, the location of where your headquarters are located, and even just buzzwords associated in your industry. Once again, unless we actively try to prevent our users from using these sort of passwords, hackers will be successful in their efforts of trying to get in. Now, before we dive deeper into Azure Active Directory Password Protection and what it offers, I just want to briefly go over the other protection mechanisms we have in place to protect your users against identity-related attacks. I did briefly go over lockout, but to recap, the premise here is that after multiple failed sign-in attempts, we do lock the user's account. But our lockout policy is actually kind of smart. It differentiates authentication requests that are coming in from a bad actor versus those coming in from a genuine user. Let's say a bad actor is performing a password spray attack. They try multiple different passwords, and fortunately, since you guys have Azure Active Directory Password Protection, they aren't able to guess your password. But after multiple of these failed sign-in attempts, we will lock the account for the bad actor, but we still let the genuine user in. Our current default settings are set to 10 failed attempts will lead to a 60-second lockout period. After the 60 seconds have passed, let's say the bad actor tries again, and so this 11th attempt is still a failed attempt, then we start those 60 seconds all over again. And if this pattern continues on, then the 60 seconds will eventually begin to grow. Additionally, we offer Azure MFA, and I'm sure that there have been many talks at Ignite about that, but it's a great second layer of protection to add onto username and password pairs. You can use the Authenticator app to get that verification code. We also have certificates, so if you're using an iOS or Android device and you're looking to log into a Microsoft Office application, we offer certificate authentications, another great way to add that extra level of protection. And then, of course, we have Azure Active Directory Password Protection. So this is the main feature that really lets you ban or restrict the passwords that you will allow from your user base, including words that I briefly mentioned earlier. And it's a great way to defend against password spray attacks, and it's the main service we'll be talking about today.
Thank you, Rohini. So I'm assuming Rohini has done already a fabulous job in scaring you, everyone, with those metrics. And what I'm going to do now is go a little bit deeper into what it really means to protect your organization with Azure AD Password Protection. And I will start with one number that should put your mind at ease. So we work with our customers, and what we found is that customers who used Azure AD Password Protection, as they were able to detect as high as 52% of the passwords being used in the organization as weak passwords. Just imagine the scale of that. The kind of surface area that it gives to the attackers to go ahead and attack the identities in your organization. They were able to use Azure AD Password Protection to actively monitor this and block the use of weak passwords and enable users to use strong passwords. Now, what are the different qualities that Azure AD Password Protection is really unique in its own? Let's go over that. First thing, it's powered by Azure. As Rohini was saying, we see billions of authentications on a regular basis. A part of those authentications is some malicious users trying to gain access. And when that happens, we do some analysis on that pattern, and we develop a list of weak strings that the hackers usually use. And that's called a global list that we maintain. And that's one of the primary lists that is used by Azure AD Password Protection to make sure that your users are not using one of those known weak strings. Of course, all your users in the cloud, once Azure AD Password Protection is enabled, they are protected by Azure AD Password Protection. However, let's talk about our customers who are in the so-called hybrid state. We know that not everyone is there completely in the cloud phase right now, so we are still moving from on-premises to cloud. And most of the password changes that are happening, they're still happening on-premises. So what about those customers? Well, now Azure AD Password Protection, what we are doing is we are bringing the same power, the same logic that's protecting the users in Azure to your on-premises environment. It's a very simple deployment that you can do on your domain controllers. And after that, all your users, whether the changes are happening on premises or in cloud, will be protected. How will that happen? So this is a very brief and a high-level overview. I'm happy to talk about it in details after the session if you want. But this is what happens. Everything starts with your password change. Any password change that is happening, if you have deployed it both on premises and in cloud, then wherever the password change is happening, it will go through Azure AD Password Protection. The first and foremost thing that we do is we normalize the string. What we are trying to do here is we are trying to mimic the thought process of the hackers. Now, our organizations have this password complexity rules, which says, have a number in your password, have a special character. And we think if we can comply with that, that's it, we are golden. So what we do, we are humans, we want to remember our passwords, we don't want to forget it. So the common things we do are, I'll replace an O with a 0, and an I with an exclamation mark, and boom, nobody knows the better. I have the strongest password in the world. But that's not true. Hackers are thinking in the same way, right? So we normalize that string, and then we do a strength check on it. So Azure AD Password Protection algorithm does a bunch of checks and then assigns a score to it. And only if it meets the threshold score, will it allow the password to be set for the identity? Otherwise, it is blocked there and then. Now, the interesting part that some of you might be thinking, it's an Azure feature. They are going to require internet connectivity to on my on-premises environment. Not going to happen. Let's take a look as to how we have solved that problem. We know that your domain controllers are in a lockdown environment. Nobody likes internet connectivity from domain controllers for obvious reasons. So you can deploy the simple domain controller agents for Azure AD password protection on your domain controllers, and it requires no internet connectivity at all. No additional steps, just simple 3 or 4 clicks, and you will be done. But then the question arises, how are we talking to the internet? And Azure in turn. So you can have a proxy agent installed on any server in your organization. It's really lightweight, which has internet connectivity. And then just make sure that the proxy agent can talk to the domain controllers. It has a line of sight. Any one domain controller is fine even. And then anytime that the domain controller agent has to talk to Azure and get new password policies, what they do is they initiate a communication to the password protection proxy agent, and that in turn would relay the communication to Azure and get all the information that is required. Now, in this, all the communication, whether it's happening between the domain controllers and the proxy, or the proxy agent and Azure, it's encrypted end to end. Now, take it further a little bit and think about how do we start to thinking about deploying it, how to get organizations started on it, right? Because if you just deploy it and start enforcing it, you might be in for a shock because, as you saw, as many as 52% of your users can be impacted. So what we have given is that you can start in an audit mode. What that means is that on the on-premises domain controllers, the agent will start functioning, and it will process all the password changes that are happening. But instead of blocking, it will raise an event in your event logs, and you can build your analysis on it, and then say, oh, OK, these are the users. This is what my education strategy is going to be for my users so that I can effectively enforce this in future, and move from there. Once you're ready, and you can just very simply go to the Azure portal, flip the switch to an enforce mode. That's all it takes to change from an audit to enforce mode. Just go to the Azure AD portal and flip the switch. So to summarize, before we jump into the demo and see it actually working, this is what we have covered so far. Azure AD password protection, it is, of course, your cloud intelligence. And you can do dynamic banning of passwords based on your known bad patterns and also some strengths that you choose for your organization. We're going to see that in just a while. And then it is especially designed for our hybrid customers in mind, and you can make sure that, yes, you are covered whether you are in cloud or on premises. And there is a unified admin experience. Everything that you need to configure, you can just go to your tenant configuration in Azure AD portal, configure from there. Your on-premises agents will always pull the configuration from your cloud. And then, of course, we support multi-forest environments and high availability architecture. Right now, this is in public preview. So we support 2 proxy agents in every forest, and it's going to expand as we move forward. With that, let's jump into the demo. OK, right. So on your screen, if you find this little dashboard interesting, I have a session on Friday that will talk more about it, but this is essentially showing Connect Health for ADFS, trying to analyze the brute force attack happening, enough of shameless marketing, and getting back to Azure AD password protection. So where you will find Azure AD password protection, it is a configuration for your tenant. So go to Azure Active Directory, and it will show up in just a second. OK, so on your tenant information, you will find that on the security section, there will be an entry for authentication methods. Anytime now. Oh, there you go. I was told this is a faster Wi-Fi, so I switched. OK, so here we are. That's what I was just mentioning, that here you find the authentication methods. If you click on authentication methods, you can go to the password protection. As you can see, it is tagged as preview. Just to give you an overview of all the settings that you see here. In the first section, we have settings for the smart lockout that Rohini was talking about. As you can see, the default settings of 10 attempts, and the default duration of the lockout, 60 seconds, is there. And you can change the settings from here itself. But I'm assuming that everyone here is fairly aware of the lockout settings, etc. So let's go and do a deep dive on the settings for the for banning certain strings that you don't want in the passwords. So the global list is available for all the users. You don't really have to configure anything for it. But if you want certain strings that are particularly interesting for your organization scenario, you can come and enforce the custom list also. You just have to flip the switch and say, yes, I want to enforce a custom list. As you can see, for my tenant, which is Fab Identity, what I've done is, you can see here 3 strings: Fab Identity, Contoso, and Seahawks. The reason behind that is, one is the organizational identity, and we know that our organization is based out of Seattle, so of course, people love Seahawks there, so we have Seahawks also covered out. And this is the section. The next section now covers how the on-premises agents will be enabled or disabled. So in here, under password protection for Windows Server Active Directory, you have the first knob that you can turn on and say, yes, enable it for my Windows Server Active Directory. When you turn it on, your on-premises agents will start talking to Azure and pull all the configuration on-premises. And next is the mode that I was talking about. You can start in the audit mode. Here you can see I've already switched to the enforce mode, but it's really as simple as flipping the switch here to change the mode and get it going. Now, this is a federated tenant, and I have my ADFS page here to change the passwords. Let's go through and see how it's going to really work. So I have the user here, John Doe. He has been prompted, hey, your password is expired. Let's change it. Now, John is tired of changing his password, so he says, well, I just saw in the news, fall is finally here. So I'm going to use fall 2018. Nobody else knows fall is here. Only I was watching the news. And I say submit, and it blocks. As you could see in the configuration here, I really don't have fall or 2018 mentioned anywhere. So it is actually, ADFS is talking to the domain controllers, as we know, and they are just using the global list powered by Azure to block these attempts. I'm going to try another one now. Say, okay, you didn't let me use fall, so bad. This is a secure one, Fab Identity 123. And this is blocked too. So as you can see, we are blocking anything that is powered by the global list, and also based on the list that you have configured for your tenant. So all in all, that's how you can have a comprehensive protection for both your on-premises and your cloud environment. And with that, don't forget to put in your evaluations, and we will take any questions. It does. So
it just tells you that we don't think that your password is strong enough, right? We're not. Right. Well,
right.
Because we don't want people to know what words we're restricting, right? Like if that gets leaked out, and that's just an advantage hackers have now. Sorry?
Those words already leaked out, that's why you're using them.
Well, the ones on the global list, correct, but not on the custom one that you configure yourself.
And it's not just the leaked password, so we also detect patterns and we.
I don't like this word.
Yeah. So.
You're choosing too simple a word.
Right.
You change the text of the event to be custom.
That's a good feedback. So yeah, so right now it uses the standard message that Windows throws, because this is an on-premises message that you're seeing, right? But it's a good feedback. We'll work on it.
How does it affect the complexity of the default domain policy?
I'm sorry?
Default domain policy. How does it affect
So the question is, how does this affect the default domain policy? That's not impacted by Azure AD password protection at all. Whatever the complexity requirements that you have, they will still be put into effect. In fact, even if you have other password filters going on your domain controllers, they will still work as good as they were before Azure AD Password Protection. This is an addition to it. It's not one or the other. Yep.
Are you scanning the password receiver against the string?
I'm sorry?
Are you scanning the password receiver against the string?
So yeah, one of the check is yes, that if it contains the string.
So if I have a complex password that has the word fall in it, I will reject it.
No, so that's a good question. So the question is, are we scanning just for the presence of the banned string, and would we fail anything that's even like, let's say 25 characters long and is really random but has fall in it, will be rejected? The answer is no. So we do check for randomness, and that's what we were talking about, that we will then assign it a score, that yes, it still meets the randomness criteria. Exactly, right? Exactly. Yeah.
Go ahead.
So going on that point, so I put some graph and I tried it. So I took our company name, for example, and the list. So if I tried company name 1, 2, 3, that got banned. But if I did 1, 2, 3, 4, it accepted it. So is that
Yes. So yeah, we are improving the algorithm process in that, and what you have mentioned is, so we are changing the logic a little bit and making it more aware of these pattern, like mix and matching, that the custom thing that you have and the global thing, and then making sure that it's still random. Yeah. We got that feedback and we're working on it.
Yeah, go ahead.
You have a on-prem GPO policy passwords, and then you've got cloud. Which one takes precedence?
This is in addition to it. So the on-premises password policy, it will still be applied, and after that, the password protection will also be applied. It's an and, it's not an or.
Okay, so on-prem lockout after 5 bad attempts, Azure lockout after 10 attempts.
Oh, sorry, I misunderstood your question. I was thinking that you were talking about how the weak password is getting. So the smart lockout, that is not available for on-premises. The smart lockout setting is not available for on-premises. Only the weak password, banning the weak passwords, that is available on-premises.
So do you have to be using custom hash name?
No, as you saw, I was using ADFS and I'm still infect. Okay, so I think we are running out of time. Yes, and but we'll still hang around for more questions, just so that we give time for the next session to start. Thanks, guys.